correct treatment does not guarantee success. Failure still occurs. Now define failure. Actual performance is lower than expected performance. Failure is not random. Failure always has a cause. Now define system structure. All failures originate from three sources: diagnosis, design, execution. Now define logic. Diagnosis error. The wrong problem is identified. The treatment targets the wrong mechanism. Design error. The correct problem is identified, but the treatment is designed incorrectly. Performance is limited by design. Execution error. The correct problem and design exist, but delivery deviates from plan. Result does not match prediction. Now define engineering rule. Every failure must be assigned to one of these three categories. No exceptions. Final condition. Failure is traceable. If the cause is identified, the next design can be corrected. Failure must be defined before it is analyzed. Now define failure. Actual performance is lower than expected performance. Now define observable patterns. Failure appears in three forms. No production improvement. Treatment is completed. Production and skin remain unchanged. This indicates no effective impact on the system. Temporary improvement followed by decline. Initial response is positive. Conductivity or permeability is not sustained. Performance decreases over time. Operational failure during execution. Treatment cannot be completed. Pressure limits are exceeded, or equipment fails. Designed volume is not delivered. Now define implication. Observed failure pattern indicates where to look for the cause. Now define root cause classification. All failures originate from three sources: diagnosis, design, execution. Now define logic of each. Diagnosis error. The wrong problem is identified. Method, design, and execution are applied to the wrong mechanism. No result is possible. Design error. The correct problem is identified, but the solution is incorrect. Performance is limited before execution begins. Execution error. The correct solution exists, but it is not delivered correctly. Actual outcome deviates from design. Now define system rule. The failure pattern must be traced to one root cause category. Final condition. Do not propose a new treatment before identifying which category caused the failure. All failures fall into three categories, but each category behaves differently. Now define diagnosis error. Problem is identified incorrectly. The wrong mechanism is selected. Treatment targets the wrong system. No matter how well it is designed or executed, no improvement is possible. Now define key consequence. Execution quality cannot fix wrong diagnosis. Now define design error. Problem is identified correctly, but the solution is incorrect. Wrong fluid. Wrong volume. Wrong geometry. Wrong propant. System is addressed, but partially or incorrectly. Now define key consequence. Design sets the performance limit. Execution cannot exceed it. Now define execution error. Problem is correct. Design is correct, but delivery fails. Rate deviates. Fluid quality is incorrect. Sequence is not followed. System is disrupted during implementation. Now define key consequence. Actual result is lower than design performance. Now define comparison logic. Diagnosis error. No result. Design error. Limited result. Execution error. Inconsistent result. Final rule. You must identify the error type before modifying the treatment. Each error requires a different correction. This slide shows multiple failure mechanisms, but all mechanisms reduce to two physical failures. Acidizing. Failure occurs when reaction happens in the wrong place or in the wrong way. Now define wrong place. Acid flows into high permeability zones. Damaged zones remain untreated. No improvement occurs where it is needed. Now define wrong way. Acid reacts too early, or reacts with the wrong minerals, or produces solids after reaction. Result. Acid is consumed before reaching damage, or creates secondary damage. Now define system outcome. Permeability is not improved. In some cases, permeability is reduced. Now define compression rule. Acid failure equals reaction out of control. Now fracturing. Failure occurs when fracture exists but does not conduct. Now define mechanism. Fracture may be created correctly, but propellant is not placed effectively, or does not survive closure stress. Now define failure modes. Propellant does not reach fracture tip. Result: short effective fracture. Propellant crushes under stress. Result: conductivity is lost. Fluid leaks off too quickly. Result: fracture is smaller than designed. Geometry deviates from plan. Result: flow path is inefficient. Now define system outcome. Fracture exists physically, but does not contribute to flow. Now define compression rule. Fracture failure equals conductivity lost. Final integration. Acidizing fails when reaction is not controlled. Fracturing fails when conductivity is not preserved. Final rule. Creating a treatment is not the objective. Controlling where it acts and how it behaves determines success. This slide shows 3 failure categories, but they are not separate. They are 3 points where the system breaks. Now define flow through the system. Fluid must reach the target. System must complete the treatment. Performance must be sustained after treatment. Failure occurs when any of these 3 breaks. Now define first failure. Placement failure. Fluid does not reach the intended zone. High permeability zones take all fluid. Damaged zones receive none. Treatment is correct, but applied in the wrong location. Now define outcome. No improvement where it is needed. Now define compression rule. If fluid does not reach the zone, treatment does not exist. Now define second failure. Operational failure. Treatment cannot be completed. Pressure exceeds equipment limits. System shuts down. Equipment fails. Designed volume is not delivered. Now define outcome. Incomplete treatment. Loss of control. System stops before objective is reached. Now define compression rule. If treatment is not completed, design cannot be realized. Now define third failure. Post-treatment failure. Treatment works initially. Then performance declines. Now define mechanism. Propellant degrades. Flow paths are blocked. Formation redamages. Now define outcome. Conductivity is lost over time. Production declines. Now define compression rule. If performance is not sustained, treatment has failed. Now integrate all 3. Placement controls where system acts. Operation controls where the system is delivered. Post-treatment controls where the system survives. Final rule. Success is not defined at pump-off. Success is defined only if performance is sustained. At this point, design is not the problem. Diagnosis becomes the primary task. Now define the approach. Do not start with the design. Start with the production response. Production behavior is not random. It contains the answer. Now define diagnostic logic. If there is no improvement at all, the system was never effectively contacted. This indicates wrong method or wrong placement. Now second pattern. Small improvement only. This means the system was contacted, but not fully treated. Cause is limited design or incomplete execution. Now third pattern. Improvement followed by decline. This means the system worked initially, but failed to sustain. Cause is conductivity loss or post-treatment damage. Now fourth pattern. Operation stops during treatment. This means the system was never completed. Cause is equipment or execution failure. Now define rule. The production curve is the diagnostic tool. Do not redesign until the failure pattern is classified. Now validate with real case. Fracture was created. Pressure behavior confirms it. No operational failure. But production increase is minimal. This eliminates diagnosis error. Execution failure. Now isolate the cause. The only remaining factor is ineffective conductivity. Now define mechanism. Propellant did not reach the fracture tip. Effective fracture length is short. Most of the fracture is unpropped. Now define outcome. Low conductivity. Limited production increase. Now final lesson. Creating a fracture is not success. Conductivity defines performance. Final rule. If you cannot explain the production response, you are not ready to design the next treatment. Failure is not corrected after the job. Failure is prevented before execution. Now define system control. There are 4 control layers. Each layer removes a specific failure. First layer. Diagnosis control. You must identify the dominant flow limitation. Measured, not assumed. If diagnosis is wrong, everything that follows is irrelevant. Now define failure if missed. Wrong method. 0 improvement. Second layer. Design control. All variables must be integrated. Fluid, volume, rate, propant, geometry. System must match formation behavior and surface constraints. Now define failure if missed. Correct problem. Incorrect solution. Performance limited before pumping. Third layer. Execution control. Design must be delivered exactly. Rate must be sustained. Fluid must be correct. Sequence must be respected. Control must be real-time. Not after the job. Now define failure if missed. Deviation destroys design. Result becomes unpredictable. Fourth layer. Feedback control. Performance must be measured. Skin. Production. Pressure response. Difference between expected and actual must be analyzed. Now define failure if missed. Mistakes are repeated. System does not improve. Now integrate all layers. Diagnosis defines direction. Design defines capability. Execution defines delivery. Feedback defines learning. Final rule. Failure prevention is not a step. It is a controlled system. Final condition. If one layer is missing, failure is built into the treatment. Everything in this module reduces to 6 rules. First, all failures originate from 3 sources: diagnosis, design, execution. If you cannot classify the failure, you cannot fix it. Second, incorrect diagnosis leads to total failure. Wrong problem. Wrong method. No improvement is possible. Third, design defines the performance limit. Even perfect execution cannot exceed a poor design. Fourth, execution defines how much of the design is realized. Correct design with poor execution delivers poor results. Fifth, placement determines effectiveness. If fluid does not reach the target zone, treatment does not exist. Sixth, long-term performance depends on conductivity. Initial improvement is not success. If conductivity is lost, production declines. Now final integration. Diagnosis defines direction. Design defines capability. Execution defines delivery. Placement defines contact. Conductivity defines long-term value. Final rule. Do not judge a treatment by what was pumped. Judge it by what is still producing. This is not a summary. This is a system consolidation. All failures reduce to one structure. 3 root causes. Diagnosis. Design. Execution. All mechanisms you saw are expressions of these 3. Now define system behavior. Failure occurs when wrong problem is selected, wrong solution is designed, or correct solution is not delivered. Everything else is detail. Now define operational logic. Production response contains the diagnosis. Failure pattern reveals the cause. If you skip this step, you repeat the same failure. Now define control system. Accurate diagnosis. Integrated design. Controlled execution. Measured outcome. This is not a sequence. It is a closed system. Now define engineering shift. You are not applying treatments. You are controlling system behavior under uncertainty. Now define forward direction. This module defines failure. The next stage is advanced diagnosis under complex conditions. Final rule. Failure is not bad performance. Failure is unanalyzed performance. Final condition. If you understand failure, you control outcome.